Hi, everyone. So welcome to the second in the Google Web Toolkit track. I'm Kelly Norton. As you might imagine, I'm a software engineer, also working on the Google Web Toolkit. I also have a particular interest in browser performance and particularly visualizing the performance data in browsers. Since GWT was released in 2006, there really have been two parallel stories that have been forming around GWT. One tells about using the Java language to build AJAX sites and using all the tools that are available to the Java runtime and language. The second one is about taking the effort that you might put into one heroic effort, one single AJAX application, and actually investing that effort back into the tools. So instead of getting just one app that pushes the envelope in what you can do in the browser, you actually begin to raise the ceiling in what's possible. Now, with browsers, performance has always been one of those huge ceilings that it's hard to push through when you start considering applications like the applications we want to develop these days. This talk is in part about some of the things that we're doing with Google Web Toolkit to try to push through that ceiling. As you can imagine, that's an effort that deals a lot with a lot of small pieces of time, measuring and looking at a lot of small pieces of time, milliseconds, in fact. But what I hope in the first segment of this talk is that I'll convince you that that's an effort that your users will notice. So what we're actually going to talk about today is, first is why worry about performance. This is an answer that everyone here probably has this is a question that everyone here probably has a good answer for already. However, I'm going to give you my answer. Maybe you'll like it. Maybe you'll stick with your answer. After that, GWT is tools. So we've always said that there was a set of things that would just be taken care of for you. There's a lot of tedium in making well-performing web apps. And GWT tries very hard to take the tedium out, at least some of it. However, while it would be really cool if GWT could just do everything for you, we don't anticipate getting there till like GWT 1.3 or something. So I'll actually talk about 4 things that you should do yourself to help your apps perform better. So let's jump right in. Why worry about performance? Okay, so I'll tell you, I have a bias, but I think it is true. The main reason you need to worry about performance is it's a usability concern. When developers talk about performance, when you start talking about users, you're actually talking about delay. Well, it turns out that we've been studying delays, how humans react to delays in computers since like the 1960s. And we even like some numbers that we've had since the 1980s. And so I'm going to share 3 of these numbers that I think are really key as you develop your own apps. So I call this a simple model for how delay affects us. The first one, which is my favorite, is 100 milliseconds. So 100 milliseconds is the time required to get a screen updated so the user sees it as instantaneous. Now, I'll show you an example in a minute where 100 milliseconds is not even enough. In fact, 100 milliseconds is the limit. All these numbers I'm going to show you are upper limits. So 100 milliseconds is the limit at which you update a screen and people see it as instantaneous. This is actually highly relevant if you're doing animations or if you're doing direct manipulation techniques like drag and drop. Now, the second number is 1 second. So at 1 second, a user notices a pause. However, there's still a nice cause and effect relationship. They click on something and something happens. It's still the same single task. A lot of people say this is the limit at which you should consider giving feedback. If you're going to have something that's going to take longer than 1 second to update, you should consider an extra device for giving feedback in your applications. And then the final number here is 10 seconds. So 10 seconds is sort of a disruptive time. And of course, these are all average numbers. I mean, some people may abandon quickly. Some people may stay around all day. It varies by individual and a lot of other factors. But this is the point at which disruption can start to occur. And people go do other things like issue some more complaints about the Facebook design. So, but beyond that, I mean, we know that users notice. We know that they notice delays in user interfaces. I mean, and the people in this room have probably, in their experience, described something as just being sluggish. Perhaps you used a more sophisticated word like janky. But you could notice. You notice when things weren't responding the way you expected it to. The real irony of this is the whole reason we're doing these AJAX applications is we aim to give users more control. And it's funny that we would then take them away by adding different delays, like updating, like running a bunch of JavaScript code and not returning quickly enough. But in fact, it goes beyond just noticing that things are sluggish. In fact, there have been some studies that show that when you add latency into the mix, people actually start to evaluate the content as being lower quality. And if you're interested in the full details of that study, there's a link at the bottom, and I think the slides will be available. Pretty sure they will. Okay, so, but, don't just trust my judgment. Let's actually try a little experiment here. So, very simple interaction here. Something you've surely seen in a web app, just a simple hover highlight, right? So I'm going to take this, and we're going to try it with no delay. And clearly it's keeping up, right? I mean, it's no problem here. So let's actually throw in 25 milliseconds. Now, at 25 milliseconds, it's still keeping up. I mean, maybe if you have the eyes of an eagle, you can discern some delay. But at 50 milliseconds, now remember I said the limit here, 200 milliseconds, but at 50 milliseconds, you start to see that we're not quite keeping up. At 100 milliseconds, I don't care what kind of night you had, this isn't keeping up. Now, so it just goes to show you that even with these numbers, you look at the maxes, there are still interactions that happen in web apps that are very common, in fact, for which even 100 millisecond is not fast enough. Okay, so hopefully that was a really quick way. If you weren't convinced that performance is important, hopefully that was a little bit of a way to convince you. Now, let's talk about 4 things GWT does for you, performance-wise. So the first thing, we've always said GWT produces fast JavaScript code. A lot of people, when they heard that GWT was a compiler, they assumed that it just did a straight loyal translation from Java to the closest JavaScript code out there. That couldn't be further from the truth. The GWT compiler is, in fact, an optimizing compiler, and I'll tell you just a few of the techniques it does in just a minute. What you actually see on the screen are some benchmarks, the results from some benchmarks. We actually took some of the Sun Spider tests, which are benchmarks you find in the WebKit rendering engine for their JavaScript engine. We poured them over to Java. The reason why we did this is because the only way to really improve performance-wise is to measure things. And so we decided that, well, if we're going to actually make the claim that GWT can produce faster JavaScript code than you would write by hand, we should probably actually check this and continue to check this. And as we make changes, we should continue to make sure that it continues to hold on its promise. And as you can see, it does pretty well here on its promise with the ones I've highlighted. And I'll show you some more in just a second. So GWT is in yellow. The bar in blue is actually the handwritten JavaScript taken directly out of the test and then run through an obfuscator just to sort of do apples to apples. And you see we do quite well. However, we don't win them all. I mean, in fact, the access binary trees benchmark revealed an opportunity. I mean, this is the whole reason why we're doing the benchmarks in general. It revealed an opportunity to speed up the way we translate Java constructors into JavaScript. But the great thing, and one thing I'll try to continue to remind you, is that GWT is a set of tools. So this is now an issue in our issue tracker. It should be fixed by GWT 2.0, and a speed up is just a compile away. So as we get faster, your apps get faster. So how do we do that? Well, it's funny because I actually steal this quote from online. We cheat, and we're quite proud of the fact that we cheat. We cheat on the user's behalf, in fact. One of the things we do, and I'll just talk about 3 things here, 3 techniques that the GWT compiler uses that we get a lot of bang for, particularly in these benchmarks. The first one is inlining. That's just simply a technique where you take a method body and you just move it into all the places where it's called, the call sites. I mean, here's a really simple example. It should be pretty self-explanatory what this code does. You create a new circle. I read Josh Block's talk, so he recommended that I declare this as the interface on the left-hand side. I do that. The GWT compiler sees, but yeah, you tell me it was a shape, but in fact it's a circle. I know that. Given the fact that I know that it's now a circle, I actually know the implementation for area. And so you see in the last slide, it actually saw, well, the implementation for area, I'll just put that in there. And in fact, this other method called widget.setText, I'll go ahead and inline that as well. And you can tell that this is actually an implementation for the Mozilla browser, because I think as Bruce highlighted in his talk, we compile specifically for the user agent. So it inlines both of these. Now it's cool because these calls have now been sped up, in some cases considerably. But the other big thing is the methods getText and, the methods getArea and setText have been completely eliminated. No need to even put them in the source. We don't need them anymore. The other big thing that we got a big bang for is a technique called string interning, which is just a long way of saying we take all the strings in your application, we remove all the duplicates, we put them in a global table. The reason why this one is important is because there are certain JavaScript engines that have garbage collector implementations that weren't really intended for the apps we're writing, notably Internet Explorer. Now, when you do an inline function inside of a JavaScript, you do an inline string literal inside of a JavaScript function, it actually causes extra objects to get created, which in turn tends to wake up the beast, which is the garbage collector, which slows down your runtime performance. So just by doing this trick alone, we get a really nice speed up on in JScript, Internet Explorer's engine, and it helps on other engines as well. Now, the last technique gets the award as the fanciest sounding one. There are a number of words for it, but tend to call it method devirtualization. It sounds really complicated, but basically what it is I take an instance method. I see that in this particular case, because I'm writing here against an interface, and when you're writing against an interface, I mean, usually that would be a runtime dispatch. So you go, oh, well, it's an interface, and this interface has this method getText. So at runtime, I actually have to look and see, oh, well, the getText method for this particular subclass is here, and I'll call that. Well, it turns out that, since Gwt does this whole program optimization, we actually see all the subclasses. So in a lot of cases, we actually know at compile time, that's actually the method you're going to call, which eliminates all this need for runtime dispatch. And in turn, we go, might as well not even make it an instance method. Because when you translate these things to JavaScript, the way you do this virtual dispatch is that you assign objects on the prototype chain, which means that at runtime, it has to walk a list looking for the method that it needs to dispatch to. No need to do it. We already know what method it's going to dispatch to. So we basically translate it to a static method. Now, once we translate it to a static method, and one of the other big things you get out of method devirtualization is it just unlocks more opportunities for inlining. And in fact, in this case, I've stopped short of where the Gwt compiler would. When we got to the JavaScript level, it would have just easily inlined the body of this method everywhere it was called. I mean, it's short, and it's particularly when you obfuscate the names here. Okay. Second thing we do. So in Gwt 1.4, we introduced this notion of image bundles, which was a really cool concept. It basically meant that you can, in your app, you could declare all the images that you were going to use, all the images you're going to use for button faces, all the images you're going to use for just any of the treatment in the UI. And what the Gwt compiler would do is it would, when it actually ran the compile, it would see all the images and resources, pick them up, and distill it into a single image. The reason it did this is because one of the number one rules for speeding up your app load time is just to simply reduce the number of HTTP requests. So if you can take all these tiny little images in an application, assemble them into one image, you could actually get a considerable speed up. And we really like that technique. In fact, we actually did a heuristic bin packing to try to even get the image down a little bit smaller. And we really like that technique. One of the things we didn't like was the fact that we still had all this CSS. And when you have CSS, it always has these little images inside of it. And these are extra HTTP requests. So we decided for Gwt 2.0 to generalize this even further. And so we've come up with this more general notion known as client bundle. Now, and you can tell by this WebKit inspector graph that you can see the huge green blob there of CSS. That's what we wanted to get rid of. So what does this look like? So this is just a really simple snippet. And by the way, client bundle is not just relevant to CSS. It actually covers all the static resources in your application. If you have static text that you're using as data, you can actually include that in a client bundle. You can add PDFs as download, pretty much anything that's static. And the nice thing about it is, as with anything that comes out of the compiler, it's given a nice hash name so that you can cache that thing optimally. But to focus on the CSS for a minute, you see here we have a really simple example. We declare a couple of images, giving it an attribute pointing at a particular resource that it'll find on disk. And then the last one, we declare a CSS resource, and we point it to a CSS file. Now, if you look at the CSS file, it has a few extra things in it. The first thing you'll notice is that there's actually an if statement that is using a deferred binding property, in this case, the browser. So we can actually write if statements around particular user agents. The second thing is that there's this sprite. So rather than having image bundles, which previously couldn't take on these images that were down in CSS, we now have sprites in the CSS which can handle both the images that you're going to use in the Java code directly and the images that you're going to use in CSS all together, and it can bundle them all together. So once you have your CSS bundled, what does that unlock? So the first thing is the CSS associated with the application not only can it be made smaller, but the download for the CSS can actually be eliminated, because you can now take the string resource that is the CSS and you can actually move it directly in the compiled code. So you've gotten rid of the download for the CSS altogether. The other thing is, something that's very important to GWT developers, obviously, is that if you have a missing resource, it will tell you. So that error, that little error icon that you have on the error dialog that you didn't think to test, if it happens to be in the wrong place or misnamed on disk, you actually find that out at compile time. The other thing is doing this, you're able to, it runs through the compiler, so you're able to do a lot of the dead stripping that you get from other parts of your code base. Another thing is, much like the JavaScript code, you now can download CSS code that is directly targeted at your browser. And this is pretty big, because many of the CSS hacks that people use introduce CSS selectors that are actually quite expensive, and they can actually have a noticeable effect on runtime performance. And in fact, for images, many of the images can actually be turned into data URLs and can also be sent down in your compiled output. So in fact, it is possible to write an application that is fully styled in GWT 2.0 and never fetch any CSS or any images. You only get the host page and the compiled script. Okay, third thing. Third thing is this new feature, code splitting. So we had a lot of people telling us, my app is getting very large, and I don't really put much on the screen when I start. What I would really love to do is just load just what I need for the first screen, and then I want to load the rest of the app later when I need it. And we thought that was a good model. But you know, we had this monolithic compilation, which we were getting a lot of good impact out of, and we really wanted to keep that in place. So we found something that actually satisfies both camps here. Now let me start by showing you the effect we get out of it. So the big red bar you see up here is just a really simple representation of how long it takes to load our showcase example over a very slow connection. We're actually using a proxy here to simulate a slow connection in GWT 1.6. So in this case, the app weighs in at about 285K. It's about 19 seconds to load the application. Now, one of the first things we did, of course, when we got code splitting working, is we went and we updated Showcase. Now, updating Showcase, as I'll show you, was pretty simple. We actually didn't change anything logically in the application. In fact, we just turned a number of synchronous calls into asynchronous calls, and we tested it. And here's what we got. So the split version, the initial download shrank by about 40%. The load time shrank by about 40%. But the really cool thing here is that even in just trying to get the data to present to you, I did the initial download and then clicked on the first link and got the second fragment before the original version would have even finished loading. So I think that's a testament to how effective this technique actually is. So what does it actually look like to do this? It's really straightforward. Obviously, you have to load code, so we want to, anytime when you need to load something from the server, we actually want that to be asynchronous for a number of good reasons. It is the right thing to do in the browser. So we turn this into an asynchronous call. You give it a callback. Previously, you would have called here, open settings view. Now you just wrap it in an asynchronous callback. This code is now being split by the compiler. Now, what does it mean to be split? Well, it's actually pretty cool. It takes everything that is inside of that callback, and it treats that as sort of a code island. And then it analyzes the actual dependencies, looking at what you would need to run that little island of code, given what you've already previously loaded by all the other split points you've hit. So it actually generates a lot of little code fragments that are specifically tailored to where you're at in the application. So this is a really cool technique, and you know, as you'll see throughout this conference, we have a lot of internal users who are using this to great effect. And in fact, if you want some good patterns on how to use this, you should see Ray Ryan's talk. Okay, the fourth thing is that GWT interoperates with JavaScript at no cost. So the classic example of this is our DOM library. So we did have a lot of people who wanted to write in Java, but what they really wanted to do is they understood the DOM, they knew how to write against all the existing DOM APIs. They really just wanted a way to use both of them together. So in GWT 1.5, we created this. We created a DOM library. That allows you to basically write what you would write in JavaScript, except it's all type safe. And of course, given the fact that you have types and the GWT compiler can see all the types, you actually get all the optimizations that are generally available to all the rest of your Java code. Now, usually when you do language interop, you end up with these wrapper objects for various reasons. And so the real magic here is that in GWT, you actually can operate directly on a JavaScript object. And in fact, this is what the DOM libraries use. But it's not something that we withhold for ourselves. You can actually use it in your own code. One of the classic examples is JSON. So say you need to handle that JSON object listed at the top. In your client code, you eval it, you get back a JavaScript object. Now, I can cast that JavaScript object to a person, and I can use that. What's actually happening here is I've declared a Java object, and I've basically said, GWT compiler, I promise that this Java object will represent some object at runtime, and I want you to just overlay it. Just completely overlay the type. So it's actually a strongly typed Java object that overlays a completely untyped object at runtime. So this is really nice because it unlocks opportunities like you saw with the DOM libraries, and it also unlocks the ability to handle JSON very efficiently. In fact, you can sort of decide how efficiently you want to handle JSON by how paranoid you want to be in checking whether properties exist. We typically just return the properties directly. And at runtime, of course, you get just property accesses, not calls to wrappers, and not methods. And of course, this is actually available to the inliner, so all this gets inlined as well. Okay, so that's 4 things GWT does for you. But like I said, I wanted to give you 4 things you should do for yourself when you're creating your GWT apps to make them as performant as possible. The first thing, and it's probably the biggest issue we diagnose, is that it makes sense that you would use widgets as the basic building blocks for your applications, but when you start to get larger apps, it doesn't necessarily fit that you would want everything on the screen to be a widget. It turns out that because GWT does a great job of bookkeeping to try to make sure you don't introduce memory leaks, that can actually add, when you get a huge widget hierarchy, that can actually add a little bit to the time it requires to build up and tear down your UI. In fact, the 2 common misuses of widgets that I like to highlight are a lot of people use a lot of nested widgets for layout. This is, in fact, something that we may have accidentally encouraged by the introduction of vertical and horizontal panel. But when you get to very large apps, that can be a bit of a problem. The second thing is that when you have widgets that contain children, you actually don't. There are techniques to avoid having each of those children be a widget themselves, because in most cases they just need to handle events, and there's a way to do that. And I'll show you 2 easy workarounds for both of these. But first, let's handle the general question, which is how do I decide if I need a widget? So it's actually really easy. Widgets, the whole core of widgets are about event handling. So if you have a thing on the screen that doesn't actually need to receive an event, you actually don't need a widget. As I'll show you, there's some alternatives there. Now, even if you do need to receive events, there's actually some cases where you can allow a widget higher up in the hierarchy to receive those events on your behalf and delegate back to you, or delegate to a piece of code that handles those events for you. And I'll show you an example of that. And then, if you satisfy both of these requirements, sure, this is probably a case where you need a widget. Now, the thing I said about a widget that has child widgets, that's really important if you have a widget that has an unbounded set of child widgets. And I'm thinking about a tree here. If you have a tree, you really have to be careful about putting widgets inside of a tree, just because you don't often know, especially if that tree is data-driven, you don't often know how large it's going to grow. And building up an unbounded set of child widgets at runtime when you don't know how long it is, that's effectively saying I don't know how long it takes my app to load. But I'll show you a way around that. So the first thing, I'd mentioned the first common mistake was you use a lot of nested widgets. To do layout. And it turns out there's a really simple technique. There are a lot of techniques to get around this, but one of the ones that I try to use here is just simply use an HTML panel. Use an HTML panel. You create you basically put the HTML in there you need to do your layout. And then strategically inside of here, you actually put an ID for where you want to embed another widget. Now, if you look at an HTML panel, there's an overload for the add method that actually takes one of these IDs. So you're able to just slip your widget into this DOM structure that you've created. Now, the other big thing about using this technique is instead of building up the DOM using document.createElement, it actually uses inner HTML, which in most cases, and in some cases can be considerably faster. It turns out that when you use inner HTML, you actually skip an entire step. When you use dom.createElement, which in fact you're doing is you're saying, create me an element, but also give me an API wrapper in the JavaScript engine because I'm going to need to do things to it. When you pass something to the parser, it goes in the HTML tokenizer, it creates DOM elements. There's no need for it to expose any of those to the JavaScript engine. As a result, you actually reduce the number of objects you create when you do it this way. So that's another big advantage of this technique. Now, I promised to work around for the second misuse. And that is, you have this widget, and it has children. And you might be inclined to say, well, and imagine this widget. I have a very simple panel in this case, and it needs a header and a body. And in each of this header and the body, I need to be able to click on it. Now, I might be inclined to just create child widgets underneath here, and then handle events directly in those child widgets, but it's really unnecessary here. And in fact, that would just cause a little bit more work I would have to do, is I would have to build up these additional widgets. So instead, I use something that is inherent in the browser, and that's event bubbling. So if I click on an element in the DOM tree, the events it receives actually traverse back up to its parent nodes, and you can use this fact in GWT widget. So in this case, I created a click handler, but I created on my widget, which is intended to be the parent widget here. And I can actually, when I receive the onClick, I actually get something that tells me what the target of that click was, and then I can use that information to then decide which of these sub-elements was actually clicked on, and then I can delegate appropriately to run the appropriate code for that click handler, all without avoiding creating these two extra widgets. Now, this is such a common problem that we have a lot of people asking us about it. They say, it's taking too long for our app to load. It happened enough that we created a little tool called Inspector Widget. And what all this does is it allows you to take a live GWT app. It's a bookmarklet. Take a live app, you click on the bookmarklet, and it'll allow you to traverse the widget hierarchy in hopes of finding some of these cases where you can eliminate widgets. So we use this a lot of times internally, and I decided to just throw it up on a Google Code project. The code is not there yet, but I'll put it up later this week. However, the bookmarklet is there if you guys want to try it. Okay, second thing you should do for yourself. Now, when you're writing client code, particularly client code that runs on the web, there's always this sort of trade-off, this fighting back and forth between what I really want to do is I'm writing a big app, so I want to put all these checks in my code. I want to make sure, I have this method, and I've assumed all throughout it that the first parameter is not null, and I really just want to put a check. But the problem is, if I put the check in there, then it's code I have to run. But we're actually talking about a set of tools again. So with GWT, you can get the best of both worlds for this. And I actually encourage people to use this advantage just to its fullest. Recognize the fact that you have a time when you're debugging the app, recognize that you have a time when you're running the app for users, make a strong separation between them. Now, this is actually sort of an example of that is in the same, this is a related example that basically points to a pattern that we've all sort of used from the Java world, but is not really applicable for programming for a client that runs on the web. How likely is it that you have a user who's going to do something about your index out of bounds exception? Probably not. What you really want to know is that something happened. You don't actually want to give them the string that's involved here. So this is usually an error that you actually want to catch at debug time. You actually don't want to know that it was exactly an index out of bounds exception when the user's running it. So what we advise instead of throwing exceptions in many cases is that you actually just use assertions. So assertions are turned on by default in hosted mode. You can turn them on in web mode by passing the -EA flag. And one of the things you'll notice is that once you put an assert in here, this, of course, disappears in a release build. And again, this is code you don't have to run. Plus, this method, which previously probably could not have been inlined, is now available to the inliner. So it's not, this doesn't apply everywhere, of course. You have to use discretion. But you should be aware of this separation between doing debug, doing release. In fact, anytime I create a new application, the first thing I do is I go in and I create two modules. I create the debug module, and I create the release module. The debug module, I use deferred binding to its fullest to try to create a bunch of tools that will help me to keep tabs on how fast the app is. I particularly use it for performance-related things. And there's a straightforward way to do this. I defined a deferred binding property in this case called app.config. It has both release and debug. And you can see I continue to define some properties here to have different things when I'm in debug mode versus release mode. And I'm careful that the implementations for release mode are just empty implementations. So, whenever the compiler tries to build the release build, it just sees empty implementations of methods, which it just gets rid of. And then, of course, I create the debug module, which just turns all this stuff on. Now, just to give you a little example of some things that we've used it for. So debug consoles are, of course, one of these. Writing to Firebug console is another thing. Even little notifications of when things are taking too long. Now, these are really important because if you don't actually address performance problems on a day-to-day basis, it often gets very hard to track them down if you wait to the end. It's certainly easier to find a performance problem when you know it's in one of 2 commits than it is when you know that it's in one of the last 3 months commits. So we use this to great effect, and I would advise this as well, that you go ahead and very early get set up with a debug mode and a release mode and use that to its fullest. Okay, so the third thing you should do is what I call avoid forcing layout. So this is the little graph you're looking at. I wanted to do a little experiment that I thought would be interesting. So there's, you guys are probably aware of some DOM properties, offset left, offset top, offset height, offset width. These are all things in the DOM API. What they're asking for is certain measurements about a particular DOM element. So I wanted to take a highly optimized application. In this case, Google Calendar. I knew that these guys had been very careful in the way they wrote this application. And I wanted to look at every time offset height was called. And then I wanted to see how long it took in each time. Well, they called it 18 times in the time that I ran the app, which was, I basically opened a few very large calendars, closed them. And among those 18, the range was from half a millisecond to 85 milliseconds. Now, you remember I started with some times that I thought were important. And if you're considering this 85 milliseconds, I mean, certainly when we did that little demo, we were sluggish by 50 milliseconds. So I've just blown my entire time required to remain interactive on one property access. So it's really hard to write against this because you oftentimes don't know how long a particular call is going to take. So I'll give you some simple techniques around this. But first, let's answer the question: why does it do this? Why does it take variable amount of time to call a piece of the DOM API? So this is a screenshot from an internal tool that my team works on. And this should answer the question. So when you call offset height, even though it looks like a property access, it's not actually a property access. You're actually running the layout engine whenever you do this. And in fact, in this case, it's 10 milliseconds to call offset height. We spent about 3 milliseconds doing style recalculations for CSS, and then we spent the rest of the time actually doing layout, traversing the render tree to get to figure out what the size of everything is. because the browser may not know at that time what offset height is, so it has to go in and compute it. So some techniques to avoid this, some techniques to make sure that, really these techniques are about, well, the top technique is about avoiding it altogether. To the extent that you can, try to actually use CSS alone. We refer to this as imperative layout. So you use this, try to use the things that are available in CSS so you don't ever have to run the CSS code to try to ask for one of these measurements to accidentally slow down your app. So anywhere you can, try to stay in CSS. If you do have to access some of these properties, the order becomes very important. It turns out that many of the browsers are actually quite lazy. You do something that invalidates some style in part of the DOM, it won't actually update the style until you ask for the property. As a result, in many cases, it's actually better to avoid interleaving things that will invalidate the style. So here's a really simple example. So say I have two widgets. If I do this order where I take widget A, I set the style name, which sets the class name under the hood, which invalidates the style, and then I immediately call getAbsoluteLeft, well, that's going to cause my layout to update. Well, then if I turn around and set the style name again, setting the class name, updating or invalidating the style, and then I call AbsoluteLeft again, well, I've just caused two of those long, in this case probably offset left, I've caused two of those long calls to happen, where if I had just arranged it where I invalidate the style twice up front, and then asked for getAbsoluteLeft later together, then I would have done much better, and then I probably would have only gotten one long property access instead of two. So unfortunately, these things are often extremely hard to spot. This is actually a hole in the developer story. We're actually working on some tools. I hope we can actually get those out at some point. Okay, so the final thing. The final thing I'm going to talk about is RPC related. Now, I like to make the joke a lot of times that some people mistakenly thought the R in RPC stood for replication. With RPC is kind of cool in that it can handle arbitrary object graphs. But the truth is you actually don't really need that a lot. Most of the time, you really want to just send over exactly what's on the screen. And people don't really look at large hierarchical graphs in a single view. I mean, we usually need something that could be made lazy so that you can view these. And in fact, we've sometimes seen apps where the application start time was completely dominated by deserializing data. They were moving over so much data that it was actually just the time it takes to get it off the RPC payload and turned into Java objects was actually dominating the app startup. So try to avoid that. Instead, return only what is visible to the user. Actually tailor your RPC services to only give the things that are going to be on the screen. Now I have a really simple example to demonstrate a choice here. So imagine that we have this, imagine we have an application that has articles. Articles, as you might imagine, consist of a title, a date they were published on, and then some relatively large content, right? This is maybe the entire contents of a blog article. So I could design my RPC objects like this. I mean, this is the most straightforward way. I would just create all those things inside of the object. I would create one remote service interface. And I would just return a list of articles, and I would display them. But more than likely, I'm going to have this list of articles that's going to consist of just the date and the title and not the content. Well, if I design it in this way, obviously I'm sending over a lot of unnecessary baggage in that first RPC request. I'm actually sending over the content. Now, it is true that I may need the content later. However, it is also true that I don't need it right now, and it is also true that users are unlikely to click on all these articles, and therefore they don't need the content for every one of them. So instead, a better approach here would be to, and there are a number of ways to do this. In fact, I'll plug Ray Ryan's talk again. He has some great ways to do this. In fact, once you start doing this, there are other concerns that come up that I'll mention. So, so instead of actually moving the content, let's just leave the content out of the payload. And we'll add another method to get the content asynchronously. So now we can get exactly what we want for the list of articles, and the content is available by another asynchronous callback at any time we need it. Now, like I said, that opens up all sorts of questions about caching. There are great ways to do that. So you can create objects to hide all this stuff inside of, encapsulate it nicely, and these sort of techniques work quite well. architecting your application. All right, so I may have been going a little fast, but that's it. That's it. I'm going to take questions after this, but first to remind you, the 4 things Git does for you: produces fast JavaScript code, loads your non-code resources quickly, splits your code elegantly with the new code splitter, interoperates with JavaScript at no cost. By the way, if you want to see, to plug another talk, Ray Cromwell has a really nice talk about a library he's been working on, Git Query, that makes really bizarre and cool use out of the overlay types that I mentioned earlier. And then 4 things you should do for yourself. Avoid the unnecessary widgets. Try to keep your widget hierarchies as slim as possible. Use debug builds effectively. Go ahead and set up those debug versus release early and use them to great effect. And share the tools if you come up with really good tools for debug mode. And finally, avoid forcing layout. I showed you some tricks for doing that. And fetch only what you want to show in RPC. If you missed the link to the inspector widget, it's there. And so feel free to use that as you wish. And I'm happy to take questions. I think we still have a lot of time left, actually. If you have questions, please go to the mic, because the last time I tried to repeat someone's question, it was terrible. I got it all wrong.
So, hi there, thanks. With the ability to bundle code like images, or I've recently learned even CSS code and various things, can you bundle JavaScript code in there as well?
You could, actually. The trick is, actually you could bundle it as a text resource. You would just have to eval it, would be the trick. Okay. Yeah, but that would work.
You talked about avoiding nesting widgets by using HTMLPanel and using IDs. But those IDs are all in the same global shared namespace, right?
Yes.
So if you've got a pretty complex HTML layout with a lot of IDs, and then you got a dynamically generated one with some function that makes them unique and stick them in, it can get kind of messy, maybe, with a lot of pluses between your strings, and it just looks ugly. Is there any tricks or patterns to clean that up?
I mean, so there are a couple answers to that. When you do that technique, yes, you have to be careful about your names. They have to be globally unique. So you do have to pay attention to that. I mean, you can actually remove IDs if you want. That actually works. It's not quite as elegant as you'd like.
What do you mean remove IDs?
Once you actually you create an HTML panel with ID set, and then you can actually remove those IDs once you have the widgets attached to them. That actually works, but you have to be really careful with it, because subtle bugs can creep in if you miss getting rid of an ID. One of the things is that once if you're here for Bruce's talk, I think a discussion about UI binder came up. So what people once knew as declarative UI, which is sort of an XML templating language that would, which basically does the HTML panel trick for you just by declaring a template. Once that's available, it takes care of a lot of those concerns. Sometimes you can actually switch, if you just have a ton of IDs, sometimes you can actually switch it on its head, and you can instead of doing inner HTML, you can sort of create the elements using document.createElement and create a widget that holds all these. But usually you just try to be careful with the names. It's sort of a balancing act. Do you have some? Oh yes, that's right. There is actually a method for generating IDs in HTMLPanel too, and to the extent that you can use that, that's really helpful as well.
Thanks.
Just a question about the fetch, what you can show with RPC.
What's that?
Fetch only what you can show with RPC. Yep. So let's say you have one page, and there's like 2 pages that they're potentially going to access. So now if we only fetch the first page, then all of a sudden we're probably stuck with the 1 second response time for them going to the next page. So I just wonder if there's any balance in that, especially Web 2.0 applications that want to appear more like desktop applications.
Yeah. So if you actually do a full page refresh, then yeah, you have to take it on. It turns out that since you're actually just sending the data with RPC, it's a lot of times you can actually send a good bit of the data. If you mean by switching pages, you're actually just getting the next payload and updating it. Now, another thing you can do is particularly if you have an application where your use patterns are someone loads it up, they spend some time reading or using the page, and then they later go to they later get more data, then you can actually load during idle time if you're careful. Now, the one trick there is that, or the one risk is that you begin loading something just when they change something in a completely different direction. But if you have if you have good user patterns, then you track those user patterns, sometimes you can actually get the content you needed for the highly probable next action in the idle time.
In your benchmarking, how do you get accurate timing for Windows Internet Explorer? I understand the timer resolution is like 15 milliseconds on Windows.
You can probably tell from some of the tools, we're instrumenting pretty deeply into the browsers. So for instance, for Internet Explorer, we're actually getting low-level calls and calling the multimedia timers. So we're getting nice, good timing on those. And that's part of the reason why. I didn't show a lot of those things running everywhere, because you have to get the instrumentation in place. So. Yeah.
I have a crazy question for you. I've been wondering for a long time why someone doesn't do this, and you guys have the biggest opportunity to actually do it, which is suppose someone writes their whole app in Quit, so it's written basically in Java, and then the browser, that's maybe, say, Chrome, and the user agent is one of the fields of HTTP, so a Chrome browser talks to a backend that's running in Quit, and the Chrome browser says, hey, I need a web page, but psst, we're Google. Okay, and the Gwit side says, well, I hear you want a web page, but hey, we're Google too. And and it says, no, don't tell anybody, but look, here's, instead of all that web crap, here's the bytecodes for the Java, and just send that over, and the Chrome browser says, okay, I'll just run that instead, and get rid of the whole browser, and we have a world where people go to web pages and they are apps.
Right.
I'm sure I'm not the first person to think of this, but it almost seems possible now, actually. Oh, could you comment?
It does seem possible. We've talked a lot about it. It's unclear. It's unclear what the balancing act is there between. So you take VMs. The V8 guys are doing a pretty good job with that VM. So it's possible. I don't know. Maybe it'll happen. Just not sure. We've had discussions about it, and we think it's pretty cool too, but I don't know. I don't know that I can comment too much. I just don't, I think it's a cool world.
Do you think it would really be a win? Because it would defeat a few other things. You'd have to have, you no longer have generic tools that can say, look at your HTML and say, feed it to a search engine with a bunch of keywords. You wouldn't be able to just display it to people who can't read by reading it to them or letting them search, So you'd have to implement all that too, but...
Yeah, and it'd take a lot of. It would take a lot of consideration from a user standpoint too, and whether JVMs are installed and whatnot. I guess it could be baked in, but.
Oh, I see. Okay, sure. You're avoiding JVM.
Sort of a related question to that, kind of. But you have done a lot of low-level instrumentation on browsers, like you talked about in the screenshots you showed. And one of the things I know, Kelly, you found is that it's not actually the JavaScript code that's necessarily limiting anymore. It's actually the other stuff, like all the DOM, and CSS manipulation and layout and so on. And so as you've looked at it, and I have seen you personally look at these things very deeply, what are the things that surprised you the most? The sort of things that are done all the time in the web that when you do it a lot, have wildly varying behavior in different browsers, or things that seemed innocuous that had really bad effects? Yeah.
Actually, there's a really good one, and that is, it is surprising. So I showed you offsetHeight taking a long time. It turns out that the time, not only is the time it takes variable across the state you're DOM in, that number is actually affected quite a bit by the CSS styles that are active. And in fact, you can actually see that number climb up if you start to introduce more descendant selectors. Descendant selectors are pretty expensive because effectively how they work in many browsers is they go and find the thing you declare on the far right-hand side first, and then they have to walk up to see if they can satisfy the selector as it goes up. Now there are certain descendant selectors like the universal selector, which basically says match everything. If you think about what that means that, okay, what you're telling the browser is take every element, now walk up the tree and tell me if it satisfies the selector. Since those styles have to be taken into account in order to answer things like offset height, you actually see that they do have an effect on these times. That was actually one of those surprising things. And the other surprising thing is it tends to affect counterintuitively some DOM calls that you wouldn't even have thought it would affect. Like we see cost to clone node go up because of CSS style matching. We're not quite sure why in some browsers they actually apply styles whenever you do a clone node when it's not attached to the DOM yet, but we actually see the times for that go up. So many things like that have been surprising. Yeah, I mean, I think that's the biggest thing. I can't think of anything else. But yeah, there's a lot of surprising and good data inside there. Oh, there's another interesting one, and that is I showed you the example with invalidating styles and sort of flip-flopping. Well, it turns out that we found some evidence on the Internet Explorer. There's actually for tables. There's actually a table cache, a table layout cache, and if you set class name, you invalidate the table layout cache. If you're just trying to update a background in that table and you just set style.background, you actually don't invalidate the table layout cache. So there's some interesting stuff in the instrumentation we're doing. And that example, for instance, would be counterintuitive and would actually go against some of the advice that has been industry standard, that you would set class names to avoid causing so many reflows in browsers. That would actually be advice that ran counter to that. So
related to avoiding unnecessary widgets. To me, that just to start implementing that seems like it's going to make more and more code that's hard to maintain because you're dumping a lot of your object-oriented into text. Why aren't you, but the question I came up with was, why aren't you guys creating more widgets that implement some of this stuff so you could give a broader set of widgets that could handle more of these low-level things?
So the good answer is we are. And in fact, the UI binder that we talked about, which is sort of the declarative markup, is intended for exactly that. We had the same observation. We're like, okay, it's kind of distressing that in order to make things fast, we're having to move things into strings. We hate moving things into strings. It runs against everything in our core. And so that's the reason why we're trying to create these other tools that are in fact checked and will do the right thing at runtime. So that stuff is coming and is definitely on our minds. So right now, if you have to do these things by hand, we tend to do them carefully, and we tend to use a lot of times generators, quick generators, which it may be a foreign concept. If it is, there's information on the website, but that's also a good way to handle a lot of these things. An advanced method, but it's available. Any other questions? All right, thank you guys.